right, let's get started. Hi, everyone. My name is Lizzie Alves. I'm part of the marketing department here at alwaysAI, and I'm super excited to be hosting today's webinar, Unlock Physical Space Analytics with Computer Vision. In this webinar, we will show you how to leverage computer vision for real-time custom analytics. Follow along as we demonstrate how the alwaysAI platform can provide the foundation for scalable and accessible physical space analytics. We will explore use cases in retail, transportation, and manufacturing. You'll get to hear from our co-founder and CEO, Marty Beard, alwaysAI's head of product and partner management, Scott Miller, and Lila Mullany, software engineer and developer advocate. Feel free to utilize the chat window throughout the presentation to ask questions, and we'll be happy to answer them as promptly as we can. If you're joining us for the first time and you're new to alwaysAI, please make sure that you visit alwaysai.co and sign up for a free account today to start your computer vision journey. Now I'm going to hand it over to our co-founder and CEO, Marty Beard, and he's going to kick things off.
All right, cool. Hi, everybody. Thank you very much. So yeah, we have a great session today. And why don't we go to the next slide, and let me just talk about a little bit about what we're going to cover. And this is a really important announcement for us. It's a major new part of our platform. And for those of you new to alwaysAI, very quickly, we're a software company totally focused on computer vision. And what we do is we help companies create computer vision applications and then deploy them out to the edge, out to IoT devices, and actually run those. And now with today's announcement and demo, you can actually analyze in real time the data that you're getting out on the edge. So we're going to go through the core concepts of analytics, and we're going to, as Lizzie mentioned, we're going to go through some use cases, and then we're going to actually demo live the product, the alwaysAI platform, the analytics product, and how you use it. And then we will take your Q&A and answer any questions that you folks may have. So if we go to the next slide, let's just kind of set up where we are as an industry. You know, we hear so much about AI and things like computer vision and so forth. But really, what's been happening is there's been this march over the last, 25, 30 years in IT towards bringing information closer and closer and closer to the point of action. And so we kind of went through the web, and then, all of us in the 2000s went through the mobile enterprise phenomena, which is basically going from a consumer use of mobile devices to now it's running my business and I have it with me 24/7. And that was providing more and more information to us right in our hand on our mobile device. We then went cloud, where it was kind of even more data, larger sets of data could be accessed from any device, not just a mobile device. And all of us suddenly had a lot more data to analyze, to assess, and to run our businesses. And we've been going through that obviously over the last decade plus. We're now even further along that journey, and AI is really helping out here. So now we're in the so-called edge. We're actually out in the world where information is being assessed and delivered and analyzed in real time. So that vision that we've always had, kind of real-time information that helps me as a manager make decisions right now to help my top line, help serve my customers better, or help me save costs. That's now actually possible with so-called deep learning AI techniques. That's actually happening. And computer vision is a major part of it because we have cameras and sensors that can do that work for us now, actually out in the world where work and life happens. So this is where we are right now. And the analytic potential is enormous, right? So it's been assessed that the overall so-called inference capacity, the actual capacity to assess and analyze the world around us in the IoT world that I've been describing, that is more than all the other technology trends combined, right? So the amount of information is going to be phenomenal. So again, like as with all information, what do we do with it? How do we assess it? How do we take the right actions? So with that, we're really excited to be stepping into this world and adding it to our platform. Let me now turn it over to Scott, who's going to take us into more detail.
Great, thanks, Marty. And thanks everyone for joining us this morning. Lizzie, if you can advance the slide. Okay, so I want to start where Marty left off. And what do we mean when we talk about physical space analytics? So first and foremost, we're really instrumenting physical space. So all those IoT devices out there in the edge, including cameras as a general purpose sensor, we're instrumenting, which means making things measurable. In the case of it, and I guess I should say, it's really useful to think about there are things you can put sensors on. There are a lot of things you can't put sensors on, like people. So computer vision is particularly useful in the situations that really aren't appropriate for a specific sensor or where you want to do a little bit more. For example, and we'll talk about these when we talk about use cases, your store or restaurant, maybe your manufacturing shop, maybe your construction zone, and then there are all kinds of transportation use cases. Again, using the camera as a general purpose sensor to generate data about the world around you or in your store. Specifically, you should think about this as analogous to web analytics, right? So if I have a website and I have analytics set up, and who doesn't these days, right? There are unique visitors entering my store, my e-commerce store. They are hitting various pages and they are doing things on those pages, right? And ideally, it's all in the service of I'm trying to get them to buy things, take them on a specific journey. So in the physical world, and you can see in the diagram here, I have cameras in my stores, and I have visitors coming into my stores. With computer vision, I can tell who those visitors are, not by name, but I can determine the unique visitors, even camera to camera. They're going zone to zone. And later on, we'll see, Lila will demonstrate the concept of defining a zone within your analytics feed. Think of a zone as, like a web page, right? I'm in this department, I'm in this part. We can tell when people are going zone to zone. And then all of that data is being sent to the web where you can access it via a public API. So now the rest of your company, the marketing department, the business users can get access to that data in real time, use it to make business decisions. So that's really instrumenting the physical world. And Lizzie, let's move to the next slide. Thanks. Okay, so I want to back up just a little bit and talk about the analytics stack that makes all this possible. It's really worth understanding the technology underpinnings. So, but first a bit of a history lesson, right? If you recall, in the early days of the web, how you knew what was happening on your site was through server logs. And you could get all the information, I shouldn't say all the information, but most of the information you needed through those server logs, but boy, was it difficult. And boy, were you dependent upon the development house. And so you had these logs, which were designed for one purpose, being used for another very inefficiently. And so while it was possible, it was, like I say, painful. Web analytics, as we know it today, with all the innovation and progress, didn't really start to take off until tools emerged that made those logs and specifically the information within those logs available to business users and marketers. All of a sudden, you had a new group in the company who could query the data being generated by the website, could ask very specific questions of that data on their own, right? Self-service. So things moved a whole lot faster, and they could begin to model parts of their business, parts of, say, their conversion funnel using those tools. That's when innovation really started to move, and that's what led to the web analytics, the vibrant space we know today. Well, so keep that in mind as we talk about the physical space analytics stack. And this is computer vision specific. So at the very base, you have models, which are statistical predictors, frame by frame predictors. There's a person, there's a dog, there's a fire hydrant, there's a product in your store. And these models are every frame of a video, they are returning what is in the frame. You've asked, tell me all the people, here are all the people. It's a lot of noise, very powerful, but there's a lot of noise. That information is fed into a tracker. What trackers specifically do is they will assign unique IDs, among other things, they'll assign unique IDs to all of those people. So rather than I have a view of my store, every frame I'm seeing people, the model can't tell whether it's the same person or a different person. The tracker makes that decision for you. So with a tracker, you can start to see unique things, right? So one more layer of information, get rid of some of the noise, make it more useful. The models, the trackers, and the API, which gives me access to that structured data, the tracker structures the data for you, are what unlock innovation. And that's what we're going to be talking about today. So it feels very much like that first set of tooling for web analytics that took this base set of information, super powerful, but a little hard to work your way through, and open it up for business users. Next slide, please. Okay, and so all this really comes together when we talk about data at scale. You have to keep in mind we're moving toward data at scale. So turning the lights on, meaning starting data flowing from your shop, is really just a start. It's fun, it's exciting. All of a sudden I can see what's happening. You know, oh my goodness, I have this many people exiting and entering per time, and they're going here and there. Super cool. But it gets really interesting and important to begin to ask questions of that data. That's always the first thing that happens. I see the data and I go, huh, boy, that's interesting. That raised more questions than I started with, right? Well, that's where you want to be. So you want to be thinking as we go through this, data generation, external, external scale, meaning I'm generating enough data that it's statistically significant. If it's statistically significant, then I can ask and answer questions with reliability. I can have faith that my data is actually telling me things and I'm not just guessing. It's no longer anecdotal. Very important. Equally important is making that data available to the people, process, and technology within your company to use it. You need both to operate at scale, and operating at scale, data scale, is what allows you to become a data-driven business. That's what we're going to talk about today. Okay, let's talk about use cases. So we're gonna talk about use cases in retail and food service, some manufacturing and construction, and then some transportation. And what I'd like to do in kind of this theme of asking questions of your data is drive this with an initial fairly high level but important question. There are other questions you could ask of your data. But what would it look like for me to put something in place, put a program in place using computer vision and physical space analytics to start to answer these questions? And what further questions does it drive, does it raise? Okay, so for retail and food service, really interesting to know what my conversion funnel looks like. So conversion funnel, for those of you who don't know, very simply is the stages, measuring the stages that a buyer goes through on their way to buy your product, right? Done all the time on the web, not done so much in physical space, mostly because the data is simply not available. But you can see how this would be important. It allows you to drive users in specific ways and make that buying process more satisfying and, you know, ultimately more efficient, right? So how might I go about this in physical space using computer vision? Well, step one is really establishing a baseline. We're assuming you don't have anything in place now. You may or may not have existing video. Totally okay to use your existing video, right? And remember the diagram before. If I have cameras up and I have a basic computer vision model, I can start to track people coming into and leaving my store, right? I'm in the frame or I'm out of the frame. I'm entering the store or I'm leaving the store. Trackers, remember, assigning unique IDs to people in the frame are really important to this. may be equally interesting. If I look at the proximity of those people to each other, I can make some pretty good guesses as to groups versus singles. Do I have families coming into the store? Do I have individual buyers coming into the store? That's super useful. I can look at zone traversal. And again, we'll do an example of how to set up and use a zone, but think of a zone in this case as maybe a department, particular section of the store, maybe it's the area around an end cap I'm particularly interested in. I can define as many zones as I want within my store, and as the people move around my store, I can tell you what zone they're in and how long they've been in that zone. So I can see very specifically the journey people take. Dwell times are really the time they spent in that zone. How long are they lingering in front of that end cap? How long are they looking at that inventory? How long are they spending in the dress aisle? What have you, however you define your zones. And then, I don't know if this is most important, but very important is the time in queue or time of service for a restaurant. Once someone has made a buying decision and they're queued up to actually purchase, how long does it take you to execute that purchase? And small changes in that number, if you can optimize it, can lead to large changes in revenue at the end of the day. So for example, if I'm a $5 million a year restaurant and I change my time of service, I decrease it by, let's say, 1 to 5 seconds per minute, which an individual buyer probably wouldn't notice that, but across a year, you're going to notice it in revenue to the tune of about 400,000 extra dollars. So this adds up to real money if you can do these small optimizations. So based on that baseline, you then want to look for patterns and correlations and codify them. So personas. Can you identify the types of people in your store by what behaviors they're enacting? So maybe I'm browsing, maybe I'm a focus shopper. Those types of people are going to do slightly different things. And you can use those personas to make decisions about how you drive people through your store. Are there hotspots in your store? Maybe those are good things where people are spending a lot of time and you want to increase capacity. Maybe they're bad things where folks are bottlenecking and not moving around the store to find the things you want them to. Either way, with computer vision and zones, you can start to see those patterns. And then finally, because this data is structured, it's queryable, and it's coming off an API, I can combine it with other data, such as the weather, such as data coming off my POS machines, whatever you happen to have around that you can use to define correlations, right? What might be leading indicators of buyer behavior. Once you have that all done, right? And that's a fairly large effort. You can start to optimize and adapt. And this is where it gets interesting because you can actually set targets to measure. So you always want to use that baseline to drive a set of targets. Where are we? Okay, cool, we know where we are. Now let's drive it forward. Like I say, small changes in those end results can result in fairly large retail and or bottom line increases. Okay, that's retail and food service. Lizzie, next slide. Okay, so I'm going to talk about manufacturing construction for a moment. And in particular, I'm going to focus on forklifts because they're kind of easy to visualize. We have a couple of use cases we can talk about. But maybe more importantly, forklift accidents cost a lot of money. So every accident costs an average, and this is according to the National Safety Council, an independent group, costs an average of around $190,000. That's direct and indirect costs, and that's average, not median, so it can be skewed, but it's significant money, right? So how do I decrease these? Well, you want to make sure you're looking at near misses. Near misses are something almost happened, but didn't quite happen. And for physical space analytics, it's particularly interesting because not only is it a great leading indicator that you're getting close to the edge of some behaviors that are going to cost you money down the road, but you're very reliant upon your employees reporting near misses. And first of all, someone has to take time to do it, doesn't always look for the employee, or they don't always know. And so it's not at all obvious that your near misses get reported in the way you would like, which means you really don't have a statistically significant data set on which to base your activity. So computer vision is perfect for this. So let's talk about a couple ways to maybe start to answer this question. Am I catching near-miss collisions? So one place to start is equipment-mounted computer vision. So put a depth camera on forklifts, right? You got to figure out how to mount it. You have to figure out battery life. But once you do that, you can now start to see how close you are to various things. You can know what kinds of things you're close to using April tags. April tags look a bit like QR codes, except they tend to be used in computer vision a lot. And you can literally, you print out April tags and you put them on things. Each April tag is unique. You identify the April tag, you identify the zone. The alwaysAI platform supports April tags natively, so it's super easy to use. And now you know what you're near, right? So April tags to identify specific locations, and you can capture events. I'm going too fast, I'm almost hitting things, et cetera, based on the combination of these two. So boom, you're going to dramatically increase the number of near misses that you catch. Maybe more interesting, but a little more challenging is using ambient video. And by ambient video, I mean cameras mounted around your shop. You may have existing feeds, you may put up new cameras, you can do a little bit of both. Kind of depends on your appetite for that, right? So with computer vision, you can provide distance and spatial information. You have to calibrate your system. So you need something of known size, but like how big your known locations and your forklifts are. So you can tell how close you are to things, right? Again, you can use April tags to very easily identify where things are in the picture. And then finally, you probably want to use something like instant segmentation. So you get a little finer grained view of the edges of the forklift. But this is interesting. There are other challenges, by the way, like lighting is a big challenge here. You have to work out your lighting. But this is really interesting because now you're going to get a little more accurate view of speed. You can start to catch things like unsafe loading, not just am I near something? Am I near something? Am I picking up a load unsafely? So you're going to, it's a little more involved, but you're going to catch a broader range of unsafe behaviors, which again, your activities could include more training. It could include different lanes for the forklifts to stay in, all kinds of things you might want to remediate here. Okay, so Lizzie, if you could move the slide forward, I want to cover one more area. Okay, so for transportation, I want to talk about, I guess, a use case that isn't very well covered or not talked about very often. So most often when you think about transportation and computer vision, you think about navigation systems. How do I make the car or bus go where it needs to go? Find basic perceptive systems. So super important because they're not possible without it. But they're also not possible, particularly buses, without in-cabin analytics. So if you think about a bus, what on earth happens when there's no driver in the bus? Opens up all kinds of things you have to take care of. So let's focus on particularly wheelchairs and walkers for public transportation, because if you don't support this community, you don't have a product offering. You're not ADA compliant. You're missing a real opportunity. So you have to support wheelchairs and walkers on your self-driving bus. You have no driver. So first of all, I need cameras, external cameras on the bus to help me see when I need to deploy a ramp. For example, I'm rolling up to a stop. If I don't know that there's someone with a wheelchair at the ramp or a walker, I have no idea that I actually have to deploy the ramp. By the way, I also have to deploy the ramp somewhere safe, so I can't deploy the ramp into the wheelchair. I have to know with certainty that that wheelchair is in a safe area and the bus is in a safe area before I do anything. Okay, let's say I get my ramp deployed safely, all's good. I need to tell when the wheelchair or the person in the walker is in a safe area. So if they're not, I shouldn't start the bus, right? Sounds straightforward. With a driver, that would be taken care of. Without a driver, I have to have this vision system to take care of that. Computer vision is perfect for it. Think of the safe areas as zones. I identify the wheelchairs. I know when they're in the safe zones. Pretty straightforward. And then finally, I need to make sure all passengers are either seated, they're in safe areas, cargo is stowed, whatever my rules happen to be, whatever my safety procedures happen to be. Computer vision can help make sure that I'm maintaining a safe environment for my passengers as I go. Again, remember, I have no driver, so I've got to substitute something for that driver. And then finally, you can use capacity counting how many people are on the bus to know if it's full. I probably don't want to open the doors to more people if my bus is full, but I certainly do want to let the next bus know that you got to hustle up because I have people waiting here for you. So all things you can do with computer vision when there's no driver on the bus, transportation use cases. Okay, so before I hand it over to Lila for a demo, just to sort of recap quickly, right? So computer vision and physical space, I should say physical space analytics using computer vision is really about instrumenting the physical world, and in particular, those situations where it's simply not possible to put an individual sensor on things, where a camera makes more sense, dynamic, people tend to be moving. You do this in part so you can start to ask questions and answer those questions in a structured way about your shop to drive business decisions. What's my conversion funnel? What happens when there's no driver on the bus? How do I take care of those questions? And ideally you do it, and alwaysAI can help you do it in a way that is scalable and meaningful. That means it's sustainable, your results are predictable, and those business decisions you're making are based on real reliable data. Okay, Lizzie, if you can advance the slide, and Lila, I will hand it over to you to do a demo. Thanks.
Thanks, Scott. Yeah, so as Scott has mentioned, I'm going to be doing a demo, and he also recapped the really important parts of the presentation so far that factor into this demo. So as Marty mentioned, he explained the importance of edge analytics in driving business decisions. And Scott has explained, the analytics stack itself, as well as the importance of getting this data to non-developers and making sure that it is queryable so that you can actually leverage it. So what I'm going to be doing now is show you how you can do this with alwaysAI, generate these edge analytics data, and send it to a secure endpoint so that it's accessible and queryable for your organization. So before we jump into the demo, you can see we have this slide that Scott showed earlier. We're just going to review this one more time to put the demo in context. So the first part is these zones that Scott has described. And so these zones are a way that you can, Scott used the word instrument the physical space. So you're mapping the physical space, your store or the warehouse or the bus to the camera's view of that space. And that way you can tell that when the camera sees something, it can relate it back to the physical space through that zone. And so I will show you how you can generate these zones a little bit more efficiently and easily in the alwaysAI system, and then use those zones directly in your application for your analytics data. And then the second part of this equation is the application itself. So the application uses those zones to generate real data about your environment, and then it can relay that data back up to the cloud to a secure endpoint where it's available for business intelligence tools or any other service that might want to access it, databases, secondary application. The point is that it's accessible, it's standardized, and it's able to be queried programmatically through any of these interfaces so that you can actually leverage it. And so with that, I'm going to share my screen and I will kick off the demo. So the first part that I will do is share how you can generate zones through the alwaysAI platform. So we have a new tool, a command line interface tool that you can use to generate zones. So the way, and if you don't already have alwaysAI, you can install the alwaysAI CLI or update your application or your CLI to get the new tool. But you'll just run it with AAI Zone Creator. And it's a Dockerized application that will run in your browser. So you can see it's pulling the latest version, and you will need to have Docker installed and running to use this tool. And then you'll need to use Chrome to run it. So you can see we have it running in my Chrome browser. This application takes either a static file or a video file, a static image file or a video file as input. So we'll select our file. This is the video I'm going to be using for the demo, so it's a nice one to use here. If you use a larger file, it will take a minute longer to load, so you can see that it's loading. And here we are in the zone drawing tool. I will only demonstrate a couple aspects of the tool, so if you want to see more functionality, you have to download the tool and try it yourself. So we can write in the name that we want for our zone and then draw it. You can draw rectangles or polygons, but I'll be using rectangles since chairs are pretty basic shape and we don't need to use anything more complicated than that. Whoops. And it's not necessary that you spell things correctly, but always helps for your analytics. And so, yeah, we have our chairs here. We can see the zones. They're in the table below. And now I'll download this configuration file. And to close out the tool, you just Control-C like any other application. So that was the first part of that slide that we showed last, the drawing the zones and getting them into a format that you can use for your application. So here I'll just show you what that zone file looks like. It's a JSON file, and you drop it directly into your application directory. The second part of that slide was the application itself. And so if you're familiar with alwaysAI applications, we have a lot of starter apps, and the application I'm going to be using is just a starter application for tracking. Scott has mentioned that tracking is very useful for reassociating objects in a single camera view, or if you're using more advanced tracking, you can do it in multiple cameras, but this will be a single camera application. So it's a basic starter app, and there's two changes you need to use in your regular alwaysAI starter app in order to enable cloud publishing of analytic data. So the first part is in this alwaysai.app.json. You may not have used this file too much in the past, but it's always been there. And so you can just add these lines to your file. Analytics enable cloud publish is true. And then the second line you need to add is just this object detector .publish analytics, and you can publish tracking results and object detection results to the cloud using the object detector instance. You can also publish classification results, human pose results, and custom results. So the classifier will use whatever you instantiated for a classifier, and the human pose results will be published using your pose estimator, and the custom results will be used just with EdgeIQ publish analytics, and it takes in a JSON serializable dictionary. So it's a very flexible format. As long as you serialize your own data, you can publish whatever format you'd like. However, if you want to get up and running very quickly, you can use all of our pre-baked serialization methods. And so what this does is it gets your data into a standardized format that's easily transmissible to the cloud. And then, as Scott mentioned, it's in this format so that you can integrate it with all of your existing other APIs, and you can ingest it into your database or, you know, a secondary application, whatever your needs are. So that's how you integrate it into your app. Those two lines of code, those two changes, super simple. And so the last bit we're going to do is we're going to run this application, and you'll be able to see the real-time data be generated, both a proof of life in the alwaysAI dashboard, and then I'll be ingesting it into a business intelligence tool, which is Kibana in this case. That's a visualization tool that is pretty standard for visualizing analytics data. So I'll be running this on an edge device, Edge Analytics. However, I've already got it installed and configured. If you're not familiar with alwaysAI, it can take a minute to do that. So it's already done. So you run AI app configure to configure your device, and then install AI app install to install your device, your application on that device. And then finally, we'll do AI app start. And so this starts the application on my edge device. The first thing that we'll see is this Cloud Writer, Analytics Cloud Writer starting, which means I'm connected to the analytics endpoint, which is a good sign. and then it takes another little second for the application to start. And then once it does, we can see the application is running. People are green if they're in a zone. So we can see everyone is in a zone. That's a really good indicator. And then finally, we can click start monitoring in our, this is my alwaysAI dashboard. You can see it's for my this project, and now we have some proof of life here. So this is just the number of times that the endpoint has gotten a message with this label, and I'm tracking people, so that's a good sign. I know that I've got my person label, and it keeps incrementing, which means it keeps getting data. So now we can see back in this app that we've got one person who's missing a chair, and so we can see that here. So this is a nice indicator of live data that our application is running, and we can see, okay, 3 of my zones are occupied, 1 of my zones is not occupied, and then this is a special zone I configured for this app that is a null zone. So that is a zone for people who are not in one of the other zones. So it might be a little counterintuitive, but this will show you if you had people who are maybe not being picked up by some of the zones that you've configured in your store. So it's an additional way to just monitor traffic if you haven't targeted certain zones already. And so we can see here that we have real-time data, and we can see that the data is changing as the application runs. And this is really important because if you're in one of those use cases that Scott mentioned, let's use retail, and you can see that people aren't in a certain zone. Maybe this zone stays empty for a really long time, and you know that this zone is chair 2, and chair 2, you know, in this respect was a chair, but let's say that it's, you know, actually my new fancy display that I've spent a lot of money on in my store, and nobody's coming to it. And you wonder why that is. Well, you can relay it back to your visual data and say, okay, maybe there's a barrier. You know, maybe I put this in a really strange spot and nobody can physically walk up to it, or maybe it's just not that compelling. Maybe it's not an interesting display, or maybe the advertising is confusing. So you can see that a certain zone is not being occupied, and you can make real-time and historical changes much more quickly than you would be able to if you didn't have this instantaneous results. And similarly, if you have a zone that is always occupied, you know, this zone is always occupied, it's a check-in chair in this case, but let's say in your retail store example, that's the waiting room, the changing room. If you have somebody waiting near your changing room for 15 minutes, they're not going to be very happy. They might put down their objects and leave. And so that's real customer service situation that could suffer. You know, it might only happen occasionally, but it can really affect somebody's experience. And maybe you've lost a customer who would have been more loyal and come back. So now you can see that you have real-time analytics generated on your edge device. It's being ingested by a third party, so we know that it's accessible, it's queryable, it's in a standard format. And if I'm a business-driven person, I'm not a developer, I can still play with this Kibana interface, and I can generate meaningful visualizations that I can then use in my business. So that wraps up the demo, and I'll pass it off to Marty now.
All right. Okay, thanks, Lila. All right, cool. So let me, you know, one of the things about computer vision, and if we can go to back to our deck and back to the slide. But one of the things about computer vision, it enables a very, very high ROI, and we've done a lot of work in this space where we've dove into a lot of analysis of the ROI for computer vision in general, but also for specific areas like retail, like manufacturing, et cetera. So let me just describe this. And what this takes into account, I mean, you know, technology trends come and go. People are always hyping the ROI of a lot of these trends. We did it with mobile, we've done it with cloud, et cetera. And, you know, when you really dive into some of that, it really depends on the assumptions that you're putting in and so forth. And here what we've tried to do is be really, really realistic and really practical. So what we've done in the ROI calculation here is taken into account the cost of the cameras on the edge, the cost of installing some of that information, the cost of a platform like alwaysAI. We charge per year. It's a SaaS subscription. It varies a bit depending on how many users you want, but it's roughly in the range of, let's call it 50 to 100,000 per year, where you can basically create as many applications as you want on the platform. People make lots of changes all the time. They change models. They want to rerun, retrain. They've got new endpoints, new APIs, new applications that they want. So it's a very, very active space. Having a platform like alwaysAI is critical. So you can make those changes. You're not always paying some outside consultant to do all the work. You've got a platform that's relatively easy to use and highly productive and innovative. And so in these cases, like retail manufacturing, basically what it's showing you is on the retail side, if you're able to optimize your floor layout and basically increase your sales, even by some modicum amount, like 5%. So you have a store maybe doing 40 or 50,000 per month. You've been able to move things around, put brands in better places, get better throughput, et cetera, taking into account the cost of a platform, the cost of some cameras, or what have you. This can rapidly drive very high ROI very quickly. What we're showing here is a 5 times ROI that you can achieve over your existing costs and your existing sales very quickly within 1 to 3 years. Same thing on the manufacturing side. This is a little bit more about identifying problems before they become costly. So you see a defect or something gets through the line that it shouldn't have. You have to back up, or you waste materials. There's all kinds of problems. Manufacturers obsess over things like this, trying to reduce wastage, trying to reduce defects. Cameras and deep learning computer vision on the edge can be extremely effective in doing that very quickly and much, much more accurately than a human. And so again, here you can see a very rapid ROI above and beyond current costs and current line production in this case of 6 times over a 1 to 3 year period. So again, we'd love to showcase more of this to you if you're interested. But there's a very high ROI from getting these real-time analytics that we just showcased for you and driving decisions much more quickly and much more smartly than you've been able to do. So let me turn it back over to, if we go to the next slide, back over to Lizzie, who I think is going to, through Lila, who's going to take us through some Q&A. Lila?
Thanks, Marty. Yeah, we do have a couple questions. So the first is, can I use existing camera feeds in this new analytics system and with alwaysAI?
Yeah, I can take that one. So absolutely, right? And in fact, if you have existing camera feeds, that's where you should start because it's a little bit faster. There's no reason not to. I think there are a few caveats there, just things to be prepared for. So we've seen changes in models depending on camera angle. So a lot of the existing cameras are designed for, let's say, there's CCTV feeds, and they tend to be top-down, sort of 360-degree views. And so you will probably end up needing to retrain a model based on that view, which is very doable, something we can help with or we can provide some guidance on. The good news is if you have any kind of a data feed existing, you already have a data set that you can use to tune your model, which is really critical. So again, talk to us. We'll walk you through some of the lessons learned, things we've been through. You do want to have sort of in the back of your mind that over time you're going to find, and by over time, this is not something you're going to hit in 12 months. This is something you're going to hit in years, right? Over time, you're going to find, this is the pattern with physical space analytics that we've seen is once you start asking questions of your data, you want to learn more and more and more. So that optimization process Marty talked about sort of in full effect. And there are going to be things you simply cannot do with your existing camera feeds because they weren't set up for computer vision. So there will come a time when you say, man, this is important enough and valuable enough, I kind of want to rethink my physical infrastructure. It's not something you have to worry about for a while, but it is again, keep it in mind for the longer term, but absolutely start with your existing feeds. Just get started.
Yeah, that's great. And when you do have to make that shift, then it won't be too painful because the platform itself will work on the new setup.
And your analytics system will already have proven out its value.
Right.
So the cost justification is very, very easy at that point.
Perfect. The next one is a question that I think we've gotten a lot in general, but is also relevant now that you are using stuff in the cloud. Is should I be concerned about privacy?
Sure, and I guess I can take this one. This one as well. So yeah, I think you have to, and in particular, so there are a couple things that folks don't think about, right? Some do, some don't. To be fair, one is preserving the privacy of the people in your store or your restaurant, right? It's arguably less of an imperative if you're a manufacturer and your employees are on the floor, right? But if it's people coming into your store, there's, particularly in European countries, there's a right to privacy, right? And so what we've done is we've added very straightforward ways to blur objects in the feed, specific kinds of objects. So, hey, it's a person, you should blur that, right? Not just the face, but you blur the whole person. So your analytics system is still counting the person, and we know fairly precisely, your system knows where the person is in the frame and all the zones and all the interesting data. But what's not available to a third party or even someone in your company who's monitoring the feed is the specifics of that person, right? What they look like, potentially who they are. So there's no real PII being transmitted. And that's one of the benefits of doing this on the edge, is that raw, unfiltered or unblurred video feed never hits the cloud. The only thing that ever hits the cloud is either a data stream, which doesn't identify people at all. It doesn't identify specific people, right? Identifies people as a class. And if you do capture video, the unblurred video is never sent anywhere. It's always blurred, right? And so you have the edge take care of your privacy. So you're not, ironically, you're not involving people. And then the other thing to be aware of, and it depends on your specific situation, but you want to be thinking of the eventual possibility that you're going to need to have an opt-out mechanism. So again, if people have a right to privacy, comparable to maybe a do not track mechanism on the web, right? So at some point, this may be an issue. Again, we have ways in our platform to enable that. It's very straightforward. So we're happy to run you through it, but not something I think you have to worry about immediately. But you absolutely want to be prepared for that eventuality.
Yeah, that's great. And I should clarify too that publish analytics method does not send up any image data. It's only JSONified textual results.
Right.
So any image data you send, at the end of the demo, would be on your own accord, and you would control how it's being presented, and you would control the endpoint. So the last question I have queued up is, do I need dedicated edge hardware for all of this? You want to take that one, Scott?
Yeah, you probably do. So the good news, right, is there's a ton of investment. And Marty spoke to this. There's absolutely a ton of investment in edge compute power, GPUs, co-processors, what have you. And the performance gains are just spectacular, right? That said, we continue to see sort of in the deployments we're doing, we continue to see most applications being performance bound. And so many of the interesting things you do with computer vision still require a good amount of hardware to accomplish them, right? And so it's really quite affordable, but you should assume that, hey, I'm not going to have a single device with, covering my 20 stores, right? That's just not going to happen. It's not very expensive to dedicate hardware. You're going to get better results. So again, something we'd be happy. We have a lot of experience with this. We have a lot of benchmarking. We provide benchmarking on all our models and applications, so that's useful. And just things we've seen, which we're happy to talk to people about. But you should go into it probably assuming that you are you have dedicated hardware, for your deployments. And I believe Marty's ROI calculations assume that as well. So the ROI is still quite high.
Yeah.
Right. And you can check out our website and see the supported devices page, but we do support a range of devices. So even if you have to scale up later, to a different device, a more powerful device in the same sort of family, you can do that without breaking your application, without breaking your pipeline. So that's,
Right. You're absolutely not locked into a single device.
Yeah.
Right.
Yeah, definitely. And like Scott said, if you want to hear more, we really encourage you to schedule a demo. And we love to walk people through in more detail, answer more of your questions. You can also email myself, Lila Mullany at alwaysAI.co. The email will be on the webinar invite. And so with that, I think that's all the questions we have for today. Yeah, so I think that does it. And thank you so much for joining today. We hope to see you scheduling some demos, reaching out to us on our Discord channel or any of our other social media. And see you next time at the next Hacky Hour and webinar.
Thanks everybody.
Everyone.